So now we look at gravimetric analysis, and this involves accurately, and here's a key word, accurately measuring the masses of a particular substance. So we use this a lot in different industries, particularly the pharmaceutical industry, the food industry, and the mining industry. And you can see here that each of these really needs to know how much mass it is. For instance, if you're a miner and you promised some company, 2,000 tons of iron, and you only could produce, 1,000, then they're not going to be very happy. And in the pharmaceutical industry, this is even more important, because if your tablet says, 200 grams of drug X, and it's actually like 600 grams, then you've probably inadvertently killed someone if you didn't get this right. In gravimetric analysis is super important in these industries for economic and even safety reasons. What will happen most of the time in gravimetric analysis for chemistry is that you'll make a precipitate or something, you'll mix two solutions and get a precipitate out, and then you'll weigh the precipitate. That's one common example. Or you'd take the measurement of combustion byproducts, take those and try and develop a empirical formula for the fuel that you use. For instance, if I took a piece of wood and I lit it on fire, or I weighed it first and then lit it on fire, then took out all of the byproducts and weighed them, I could actually develop an equation or a formula for the chemical composition of wood based on my byproducts of combustion. So those are the two typical ones that you'll see. Weighing precipitates, which we'll cover a lot in Year 12, and developing empirical formulas for complex fuels using combustion. So that concludes today's lesson on gravimetric analysis. We looked at what gravimetric analysis is and what chemical analysis is as a whole, and what are the different subgroups of chemical analysis.